Bismillahirrahmanirrahim. Hi, I am Yaseen. This course is designed as Introduction to Computer. Now we try to learn number system in this video clip. What is the number system? A system which contains the numbers not manipulating but process and calculation. Number system is the system of counting and calculation. In number system, characters called digits. Number system based on characters. We have four types of number system: the binary, the octal, the decimal, and the hexadecimal. In the binary number system, we have two states, 0 and 1, yes or no, on and off. It has base 2, ideally for internal working of electronic computers. In binary number system, every number value represent with 0 and 1. A binary number system is a sequence of the digits 0 and 1. The octal number system. Octal have 8 states and digits. It will start from 0 ending on 7. You say 0 to 7. The all digits are as 0, 1, 2, 3, 4, 5, 6, 7. The base of octal number system is 8. Let's suppose octal is a language. If octal is a language, then it have 8 alphabets, and all the words are the concatenation of these 8 alphabets. The next one is decimal number system. In this number system, we are start from 0 and ending on 9, usually in common life, used in common life, have base 10. Every number value represent with 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. It have 10 digits. If we take a decimal number system, or suppose a decimal number system is a language, it have 10 alphabets, and all words are the concatenation of these 10 digits, which is 0 to 9. Decimal have 10 states, digits or division. The last one, the hexadecimal number system, start with 0 and ending on F. It represents as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E and F. Whereas A is equal to 10, B is equal to 11, C is equal to 12, D is equal to 13, E is equal to 14 and F is equal to 15. Hexadecimal have 16 digits, states or division have base 16. The hexadecimal number system has 16 alphanumeric values having base 16. Let's suppose hexadecimal is a language, and 0 to 9 and A, B, C, D, E as well as F are the alphabets. So all words are the concatenation of these 16 alphabets. So, type of conversion system. Before we are going to the conversion system types, firstly, what is the conversion? The number system: binary, octal, decimal and hexadecimal. whereas the binary convert into octal, octal convert to decimal, decimal convert to hexadecimal, or hexadecimal convert into decimal. It is called conversion. Here, 6 type of the number system conversion in our course: the binary to decimal, decimal to binary, octal to decimal, decimal to octal, hexadecimal to decimal, and finally decimal to hexadecimal. Now we are rearranging these things as these are the 6 type of the conversions, and now we are rearranging in the simplest form, which can make easy for us: the decimal to binary, decimal to octal, and decimal to hexadecimal. Here I am sharing a tip. These all 3 are starting from decimal, so we take LCM in this case. And the second tip, ending with decimal, we do multiplication. The binary to decimal, octal to decimal, and hexadecimal to decimal. In this case, we are multiplication because the decimal in the end of these convergent system types. And the video has been directed in a such way which will make you easier to understand hexadecimal to decimal and decimal to hexadecimal convergent system. In our case, we take a numerical which is 11,809 base 10 is equal to, within a parenthesis, question mark 16. Here the convergent system start from decimal, so what we take? What we do? We take LCM. Yes, of course, take LCM. Here 11,809 divisible by 16. So 1 is not present in the table of 16. What we do? Take another digit. The first one is 1, the second one is 1. 1 concatenate with 1. The number is 11, and 11 is also not present in the table of 16. So what we do? We take the third digit. Now this time concatenation of 118 is 118, and 118 somewhere in the table of 16. So 118 divided by the 16, 16 multiplied by 7 is equal to 112. The 118 minus 112, remaining value is 6. The 6 concatenate with the 0, which is 60, and this time 16 multiplied by 3, the result is 48, and 60 minus 48, the result, the remaining value is 12 at the time. So 12 concatenate with 9, the value is 129. This time 16 multiplied by 8, which is 128. So 129 minus 128, remainder is 1. The first remainder we get 1, and here is this, here the 1 is the least significant bit. Okay, now the new digit, the new number is 738 divided by the 16, and we take 73 because 7 is not present in the table of 16. So concatenate the second digit, which is 3 with 7. So 73, 64 is 64. 73 minus 64, the result is 9. 9 concatenate with 8, which is 98, and 16, 6, the 96. So 98 minus 96, the result, the remainder is 2. Now write here 2. Now 46, the new number is 46. 16 multiplied by the 46 in third steps. 16 to the 32, and 46 minus 32 is equal to 14, which is here. Okay, now here 2 in green color, which is the most significant bit, and 1 in brownish red color is the least significant bit. Here in yellowish orange color, 14 is not present in the hexadecimal number, so we use the equivalent of 14, which is E, when we write the answer. So 1 is the least significant bit, 2 is the most significant bit, and the answer right here 2E211. From down to up, right here 2. E is the replacer of 14, then 2, 1 is the base 16. This is the answer. Now we check, or we doing the next conversion system, which is hexadecimal to decimal. We take the same answer of 2E21 base 16. Then if the result is 11,809 base 10, the answer is true. Elsewise we do some sort of a mistake. Okay, now 2E21 base 16. What we do here? Here is decimal, here is hexadecimal convert into decimal. So what we do here? Simply multiplication. When any conversion system ending on decimal, we are multiplying. We just do the multiply. Here 2E, here 2E21 base 16. Within a question mark, within a parenthesis, base 10. Solution here. Now what we do? 2 cross 16, the same base value. The arrows shows that the 2 cross 16 plus operator, then E cross 16, then 2 cross 16, then 1 cross 16. Now assigning the powers from right to left: 0, 1, 2, 3. Here sometimes students do the silly mistake. They do 16 multiplied by 2, which is 32. Here is 2 is the power. That means 16 multiplied by 16. Okay. Now in second step, in green color 16 cube. That means 3 times 16. So right here in the parenthesis, 16 multiplied by 16 multiplied by 16. E is equivalent to 14. So right here 14, and 16 is square. So 16 multiplied by 16, 2 times 16. Now 2 multiplied by 16, because 16 have a 1 power, and the last 16 have 0 power, which is not, and anything which has the power is not, the result is 0. So right, not 0, sorry, anything the power not is, the result is 1. Okay, in third step, 16 multiplied by 16 multiplied by 16 is 4096 multiplied by 2. 16 multiplied by 16 is 256, and 16 is 16, and the 1 is 1. Now 2 multiplied by 4096, the result is 8192. 256 multiplied by 14, the result is 3584. 16 multiplied by 2 is equal to the 32, and 1 multiplied by 1 is equal to 1. The result is 11,809 base 10. It's confirmed, we are right. Okay, this is the end of the conversion system of our course. Here I'm showing with arrowhead where n naught is equal to 1, n is the power naught is equal to 1, anything which has the power naught is equal to 1. If you are saying about 5 rupees is the power naught, that means it's not a 5 rupees, is the 1 rupees only. okay, and the 16 which is in pink color is 1 because 16 is the power naught. Okay. So now we take an example of 19 base 10 converting in binary number. This is example number 1. 19 base 10 is equal to question mark base 2. Need the solution. First of all, we take the LCM of 19 as working. So make LCM. Here is 2 and 19. 19 by 2. Okay, 2 9s are 18. So 1 reminder. 2 4s are 8. So again 1 reminder. Whereas 2 2s are 4 and 0 reminder. Whereas 2 1s are 2. Yeah, oops, 2 1s are 2 and again 0 reminder. Here is the 1. This one is the most significant bit which I highlighted, and this one is the least significant bit which I highlighted now. So I write here the 1 is most significant bit and the 1 is least significant bit. I will change the color, the best understanding for us. Now we write as downward to upward, like as I copy and paste here for ease of me. base 10. Here I write here the most significant bit is 1, which is this. I copy and paste here. Ease for understanding of your. The 0 no, it's not good. So again copy and paste, not cut and paste. I do the cut and paste. Now 1, that one is 0 here. It's highlighted 2 for better understanding of us. The second 0, the third one, the fourth one is 1, the second last value of this LCM result, and in the last the least significant bit, which is 1. Copy. The conversion of 19 base 10 is equal to 10011 base 2. This is the result. I write here the result. See, this is the end of the story. Decimal to binary for the purpose of checking. If you need, you can convert binary to decimal. But remember it, binary to decimal conversion is another conversion system, but it helps you to checking your answer is correct or not. As result shown, 19 base 10 within a parenthesis 10011 base 2. In our course, when any system ending with decimal, we multiply the binary value with a subscript like as 10011 base 2 is equal to, within a parenthesis, question mark base 10. I am discussing about this. The problem number 2 is the conversion of binary number system into a decimal number system. Also the checking of this result, which I highlighted. So I also the color will change. This is the result of base 10 equivalent to this 10011 base 2. Here the same question is 10011 base 2 converting in base 10. So I do the solution here in tabular form. The 10011 base 2 is equal to, within a parenthesis, question mark base 10. Now I'm solving this. Again. Okay, now do that. The important concept here, any value has power 0, the result is 1. My means a is the power naught, like as a is the power naught, the result is 1. Similarly as 465 is the power naught is equal to 1. It's mean if any millions or billions digit value is the power naught, like a small 0, like as here, the value is 1, is equal to 1, the result is 1. So this is the rule of math. Any value has power 0 is equal to 1. Here you show the a is the power 0 is equal to 1, 465 is the power 0 is equal to 1. Now, and any value which multiply or divide by 0, the result is 0. Anything, any numeric value, any alphabetic variables multiply by 0, the result is 0. Now I'm solving this. Hope it's really easy for you. Yes. Here is this the most significant bit in blue in color. The 1, here is 1. First of all, I write here 1 cross 2 1. I solve by myself. Leave it. Now 1 cross 2. This one, the first one, the most significant bit. From left to right, we are writing here from left to right. 1 cross 2 plus 0 cross 2, then plus 0 cross 2 plus the second last is 1 cross 2 plus key sign, then 1 cross 2. Here you see this 1 cross 2 is the most significant bit, and these values are the middle values. I change the color for better understanding of your. The 1 cross 2, the last one, I change the color is similar like green. Yep, here. So assigning the powers. First of all, how I write? I am writing from left to right like 1 0 0 1 1. Okay, like here the most significant bit is 1. Here is it. If I color it in 0 is someone else colors for better understanding of you, I choose the red one. Here I choose this, complete the red one. Achha, now this one is choose another color like or blue. Yeah, blue, I have blue already. Chalo. Okay, this one light blue. So again this one is the same one, and the one is black and it is the black. Okay, the last one, the least significant bit in green in color, the 1, here is this one. And multiply by 2. Why the multiply by 2? The base value is 2. This one. This one. That's why I multiply by 2. Hope you are understanding this pattern of the convergence system. Yes. Okay, done it. Now oops. The good thing is here right now. Okay, the 0. Now assigning the power. Here is 2. Starting from right hand side to giving the assigning the power 0. I select the 0, Control Shift plus in Microsoft Word. Like here 1, Control Shift 1 in Microsoft Word, Control Shift plus in Microsoft Word if you are using Microsoft Word. Assigning the power to. Did you see what I do? So first I assign power 0, then 1, then 2. I change the color. This color is not visible in my view. I change it in some else other dark color. Yes, this is good. Okay, this one is okay, the similar color. Also bold it. Okay, now the 0, 1, 0, 1, 2, now 3. Assigning the power 3. Now this is the power. Now 4. Now this is the power. That means 4 times 2. It means 4 times 2. My means 1. I copy here. I copy it and then paste here. 1 cross. I delete the power here. Now 2 cross 2 cross 2 cross 2 cross 2. They are 4 times 2. 1, 2, 3 and the 4. Okay, now the plus. Now the sign of plus. Here 0 multiplied by any value, the result is 0. The rule of math, the rules of simply math, the basic math. So right here 0. Don't need to do the hard, complex calculation, and life make easy. Again 0 cross 2 is the power 2. So right here 0 again. Then plus 1 cross 2 means 1 cross 2. Oops. 1 cross 2. Because 2 contain only one power. 2 contain only one power. That's the reason here I write here 1 cross 2. In the last, there an important concept of this conversion or the algebraic rule. Any value have the power 0 or you say not, that means its value is 1. Whatever the value of figure in billions, millions, whatever. Okay. So here I write 1 cross 1. I choose the same color. One cross 1. This one is the result of 2 to the power naught. Okay. Now the easiest way to saving the punching the key here, yes, is equal to what's the result? 2 to the 4, 4 to the 8 and 8 to the 16. So 1 cross 16, then 1 cross the 16. 1 cross 16. The 0 have no value here, so eliminate these zeros. 1 cross 2. 1 cross 2 and 1 cross 1 is the important, so I copy paste here. This is in blue in color and that was in black in color for your better understanding. Now the result again, actually okay, now 1 cross 16 is equal to the 16 plus 1 cross 2 is equal to 2 plus 1 cross 1 is equal to 1. The result is 16 plus 2 is equal to 18. 18 plus 1 is the result is 19. The result is match. The result is match the 19. This one. Right here the answer of this question as S. So you have noticed that here 10011 base 2 is equivalent to base 10. I am highlighting this in gray color, also not in gray color, to choose someone else color which is really helpful you. Okay, and the result one. Okay, now you can see the result is same, the 19 and the 19. The 19, I am highlighting it, not highlighting, I am changing the color here, the yellow. Yes, yellow is best as per contrast. Now this one, yellow. So, hope you are really enjoying this video clip. Maybe it's really helpful for you. This is the end of story today's. Decimal to binary and binary to decimal conversion. We are done. Two sort of the conversion here is up. The story is end. Bye bye.